Good morning, all of you. Now, okay, let us start analysis of Bull Cat 2, Quant and AR section. Yeah, question number 8. That was a difficult question. Yeah, any problem in this? What is the answer for this? This is option third, option number 3. Question can be answered by using the information contained in both statements together. Yeah, any problem in this? If you want me to explain this question, please write explain in chat box. Yes, Ayush? Okay, let me explain. See, 3 integers are written on a board from left to right. The first, second and third integers are P, Q and R respectively. Which is the largest of these integers? What is the first condition? First condition is 5 times the first integer equals 3 times the second integer, 16 times the second integer equals 15 times the third integer. I'm not taking the third condition first, once. I'm solving these two. If I take the very first thing, 5p is equal to 3q. Can I write p by q is nothing but 3 by 5? From here I can say q by r is equal to 15 by 16. Now I'm clubbing these two things. P is to q is to r. Because that is a comparison question, we want to calculate which is the largest one. That's why I'm considering ratio. So I can say P is to Q is 3 is to 5 and Q is to R is 15 is to 16. Now I want to calculate the compounded ratio. I'm in the joint ratio, the combined ratio of P, Q and R. Now at one place Q is 5, at another place Q is 15. So I'm multiplying the first ratio by 3 to make Q equal. So its joint ratio will be 9 is to 15 is to 16. Any ratio can be multiplied by any number or can be divided by any number by without changing the ratio. We cannot add up any number or subtract any number from ratio, but we can multiply or divide any number. So P is to Q is to R. They are 9, 15 and 16 comparison wise. Now what was the question? Which is the largest of these integers? See this word, integers. Integers can be positive, integers can be negative. If I consider positive values only, I can say R is the largest. But what if I take this ratio, minus 9, minus 15 and minus 16? In this case, P will be the largest. Since we are considering integers, all the positive as well as all the negative values are allowed. That's why we will consider both these cases. In one case, R becomes the largest one. In second case, P becomes the largest one. That's why by using statement 1 alone, we cannot answer this question. Now I'm taking second thing. Second statement says the product of 3 integers is greater than q square. Product of 3 integers is greater than the square of second integer. That is P, Q, R is greater than q square. If q is positive, q can be cancelled. Now there can be numerous cases. Let me take q as 1. So P I am taking as 3 and R I am taking as 2. Now P and R, they can be 3 and 2 respectively, and P and R, they can be 2 and 3 respectively. Both these values are possible. That's why we cannot say whether P is greater or R is greater. There can be many cases. Since I am getting 2 possible cases, that's why this statement alone is not sufficient to answer this question. But what if I club these two statements? P, Q, R. From first statement, I got 19 is to 15 is to 16. From second, I am getting P, R is greater than Q. If I take the very first thing, it will be 9 into 16 greater than 15, which is obviously true. If I take second thing, it will be minus 9 into PR. But I cannot take this since Q is positive. So I'm considering the another thing. PQR is greater than Q square. It will be minus 9 minus 15 minus 16 is greater than minus 15 whole square. Obviously, which is not true. A negative quantity cannot be more than a positive quantity. That's why we are left with only one case. That's why we can say that by using both these statements together, we can answer this question. Is it okay? Are you getting me now? Charu? Please, are you getting me? Okay. Ayush, if you have any other method, please write in chat box. Now let us move to second set, question number 13 to 17. It was a medium set. I'll not say that it was a difficult set. It is a medium. Is it okay? 13 to 17. If you face any problem in any question from 13 to 17, please write the question number in the chat box. Yes, 14 and 17, 16 as well. Okay. Sally sends Jack a packet from 5312 to 5314 using the rush service. If Jack is to spend the same or less during the rush service, how many different places can Jack send the packet? C. 5312, 50,314 using the rush service. 5312 to 5314. E using the rush service. If E using the rush service, what is the cost? $15.79. Come to the question. If Jack is to spend, from previous question we can say Jack is staying at 5314. Jack is to spend the same or less using the rush service. How many different places can Jack send that packet? I think Shivam, you have marked the first option. Yes. Okay. See, Jack, who is staying at 5314 and using the rush service. Less than that. Okay. Less than 14.79. Under rush service, how many possibilities are there? A, B, C and D. Its cost will be less than 14.79. Now I'm going to 5314. Now how many A, B, C, Ds are there? 1, 2, 3, 4, 5, 6. That's why this is the answer, 6. Is it okay, Shiva? Is it okay? Why not E? See, what is my question? We need less than 14.79. At E, the cost will be 14.79 exactly. That's why we will not consider E. Once again, Raghav, see, Sally is staying at 5312 and she wants to send a packet to 5314 using the rush service. First of all, I am considering this 5312 and 5314. What is the availability here? E. At E, what is the rush service cost? 14.79. Now Jack, who is staying at 5314, he wants to invest less than 14.79 using the rush service. Now I'm going to rush service table. Less than 14.79, there are 4 options. They are A, B, C, D, because its costs are less than 14.79. So Jack can use either A or B or C or D. Now I'm going to 5314 as well. Now how many places are possible where A, B, C, D are written? So these many places are possible, these many combinations are possible. And how many combinations are there? They are 6. That's why this is the answer. See, 14 in 14 we have different places. So we will not consider Jack's place. That's why. Dinesh, this is mentioned, less using the rush service. That's why we will consider only rush service. Shivam, is it okay with you now? See, we have a word different here. We cannot use Jack's place. Okay. Now another problem was 16th question. Stephen has $20 with him that he can spend. How many combination of sending receiving cities are possible in this budget? $20. Now I'm coming to table once again. Okay. See, less than $20, there are many services. Can he say, I can use A, B, C, D, E, F, G, H as well, because in H, $18.95 and $18.21 are also mentioned. Since type of service is not mentioned, I can consider anything. So I cannot use I and J. I can use anything from A to H. Are you getting me, Amisha? Okay. So I will count all the A's, B's, C's, D's, so on up to H's. It's better if we go by vice versa case. See, there are 12 things. In there are 12 columns. So how many total things are there? There are 144. But we cannot consider I and J because in these two cases, cost is more than $20. That's why I'll not consider I and J's. And in total, how many J's are there? 4. And there is no I. That's why I'll subtract that. So how many combinations are available? 140. Is it okay, Amisha? Should I proceed further? Does not matter. Amisha? Okay. Now come to 17th question. Joe is at point 53:15. Jerry has to send him a packet which needs to reach Joe by 1 p.m. Jerry would be at home at zip code 5317 till 10 a.m. after which he'll go to office at zip code 5322. Jerry he's at home. This is the zip code of home. He's going via 5312, that is Midway. He's going to office, that is 5322. Complete thing takes 1 hour, that is a complete journey, and he is leaving at 10 a.m. So at 10:30 he'll be at Midway, and at 11 a.m. he'll be at office. Now he wants to send a packet to Joe. Joe, who is at point 53:15. Now we'll use all the options. Which would be the cheapest option for Jerry to send the packet? I am explaining only one option. For example, if I take one, standard from home. Home 53:17. Jerry wants to send a packet from 53:17 to 53:15. 53:17 to 53:15. This is H. at H by using the standard service, what is the cost? 18.21. So by using first option, we can say $18.21. That is the cost. At 10 a.m. it is sent. At 1 p.m. Joe will receive it. Now come to the fourth option, standard from Midway. See, Midway is 10:30. Standard option will take 3 hours. If it will take 3 hours, it will reach by 1:30. Automatically this option is rejected. Why? Because my constraint is Joe should get this packet by 1 p.m. By using the standard service, which will take 3 hours, we cannot do this. Now I'm taking the second option, standard from office, 5322. Again, in the same way, this option is rejected. I'm coming to fourth option, I think, which is the answer, 2 hours from Midway. First of all, at 10:30 is reaching at Midway. By 12:30, Joe will receive this packet. So this is a valid option, but I'm checking the cost now. Midway zip code is 5312 to 5315. 5312 to 5315. This is 5312 and this is 5315. This is E. E. Cost is less, that's why we can mark this option. Is it okay now? Ayush? Is it okay? Okay, let us move. Yeah, question number 21. It was a difficult question. Many cases. Okay, should I explain this question? Okay. A bag contains 6 balls, has at least one blue and at least one white. It is not known whether the bag has balls of any other colors. 2 balls are drawn at random and it is found that one ball is blue and the other is white. What is the probability that the bag contains 3 blue and 3 white balls? See, one color is white, one color is blue. Whether we have any other color or not, we don't know. So I'll take all the possible cases. There is one more condition, at least one white ball, at least one blue ball. And in total, how many balls are there? There should be 6. So I'm considering all the possible cases. First of all, I'm taking this as 1. Let there be one white ball. So we are left with 5 other colors. Now since blue should be at least 1, I'm considering all possible cases. 1, 4, 2, 3. I'll consider 3, 2, 4, 1, 5, 0 as well. Because blue should be at least 1, other can be anything. It can be 0 as well. So how many cases are possible from this? 5 cases. Similarly, we'll consider this for 2. I'm taking 2 white balls. To make it 6, 4 is the balance. So I'm considering this as 1, 2, 3, 4. See, I'm not interested in finding all the cases. Rather, I want to count all the cases. So how many cases are possible? 4. Now I'm considering this 3. Again, the balance is 3. So I'm considering 1, 2, 3. 3 more cases. Again, I'm considering 4. If I take 4, it will be 1, 2. 2 more cases. Now I'm left with the last case 5, where 1 is the blue ball and 0 is the another ball. So how many cases are possible? 5 plus 4 plus 3 plus 2 plus 1. That is 15 in total. So these many 15 cases are possible. Now what is the definition of probability? Probability is number of favorable cases divided by number of total cases. What was the favorable case? There should be 3 blue and 3 white ball. That can be done in only one way. When there are 3 blue and 3 white. And what will be the number of total cases? That will be 15. That is 6.67%. That is the answer. Is it okay with you? Yes, all of you? Once again, Vasudha, see, I have written probability definition. What is probability? That is number of favorable cases divided by number of total cases. We have counted all the possible cases. How many cases are there? There will be 15 in this case. And we want the probability of exactly 3 balls, 3 blue balls and 3 white balls. There will be only one possible case, and that too is this: 3 white, 3 blue and 0 another ball. So there will be only one favorable case. So I'm putting the values in the definition. It will be 1 by 15. And what is the value of this fraction? This will be 6.67%. That is the answer in this case. Is it okay, Vasudha, now? Okay. Okay, question number 24. Very good question. Any problem in this? Okay, see, before explaining this question, let me take a smaller example. We know the value of x plus y whole square, or x plus y whole cube, we can say. What is x plus y whole cube? It will be x cube plus y cube plus 3x square y plus 3xy square. Suppose the sum of all the coefficient is asked in this case. So what will be the coefficient of x cube? It will be 1. What will be the coefficient of y cube? It will be 1. So what will be the answer in this case? It will be 1 plus 1 plus 3 plus 3. So what will be the answer? 8 will be the answer in this case. See, now that was a smaller example. We could find the expansion, then we can take the sum of all the coefficient. But in suppose expansion is not possible. Suppose directly we can say, see, we need sum of all the coefficient. We don't need these variables x cube, x square, y square. So to make it invisible, I am putting x as 1 and y as 1. So it will become 2 cube is equal to 1 plus 1 plus 3 plus 3. Or to be very precise, can I say if we take variables value as 1, we'll be left with all the coefficient with positive sign between them. Can I say this? So I can do this trick anywhere. I can use this trick anywhere. So by putting variables value as 1, we can get the value sum of all the coefficients. So I'm coming back to question. Now my question was this 24th. What is asked? Sum of coefficient. So if I put x as 1, I'll be left with 743, 744. So it will be 1 into 1, 1 always. That's why none of these. See, Namit, if this is x minus y whole square, coefficient comes with sign. Once again, Namit, your doubt. See, if you want to find the sum of coefficient of this will be 2 cube. If you want to find the sum of coefficient of this, it will be 0. Why? Whenever you take coefficient comes with sign. But if you want to find what is the sum of all the coefficient with positive sign, or to be very precise, I can say my question becomes what is the sum of modulus of all the coefficient. So put x as 1 and y as minus 1. Cancel the negative sign by introducing one more negative sign. So it will be 2 cube 1 again. Are you getting me, Namit? But if you asked sum of coefficient, it will be 0, of course. It's a nice expansion. Okay, there is one more question for you, all of you. Please answer it. It's a CAT question. Suppose what will be the number of terms, number of like term, or we can say what will be the number of distinct terms in this expansion. Okay, what will be the answer in this case? Yes, all of you. We have discussed this concept earlier also in Bullcat 1. What will be the number of distinct terms in this? Yeah, any one of you. No, not 14, Manish. You are applying binomial concept, but this is trinomial. I mean with 3 terms. No, this is not. 15C2. Abhishek, can you write the explanation? Very nice. 15C2. See, what is the thing? If we take any term of this, it will be some coefficient, x raised to power a, y raised to power b, minus z raised to power c, where a plus b plus c should be 13 always. Yes, Abhishek, very good. Can you say this? You generalize the binomial thing. Sum should be 13 always. So, how many solution to this equations are possible? We have discussed in Bullcat 1. It will be 13 plus 3 minus 1, C3 minus 1. It will be 15, C2. That will be the answer in this case. So many terms, not 13 or 14. Is it okay, all of you? I have used this formula once again. I'm writing. Number of positive integral solutions to this equation. Answer will be n plus k minus 1, ck minus 1. I'm using this. Okay, let us move. Question number 29. Good one. Very good question. Yeah, any problem in this? 29 and 32. Both were difficult question. No, 25. Raghav, you are asking me 25th question. I don't think it's a difficult question. You can ask any other question after the session. I'll give you 5 minutes. I have to open my PDF copy. Okay. I'll give you 5 minutes after the session. You can ask any question then. Okay, what about 29? I'm picking all the difficult questions. Yeah, if you want me to explain this question 29th one, please write explain in the chat box. Okay, Amrit. See, there is a staircase of 10 steps. In how many ways can Amit climb the staircase if he can take a maximum of 3 steps at a time? Okay, nice one. See, let me consider, first of all, I want to explain the meaning of the question. Let number of steps, I'm taking smaller cases. Let number of steps are 1. So I'm writing ways here. In how many ways you can climb the steps? 1 only. That is 1. At max, you can take at max 3 steps. Now suppose there are 2 steps. One way is 1, 1. One way is 2 alone. Suppose we are considering 3 steps. In total there are 3 steps. One way is 1, 1, 1. One way is 2, 1. One way is 1, 2. One way is 3. Till the moment. Is it okay with you? So how many ways are there? 1 in first case, 2 in second case, 4 in third case. Now let the steps are 4. Here comes the magic. Now at first either I will take 1 step or 2 steps together or 3 steps. If I am taking 1 step, I am left with 3 more steps. And these 3 steps can be taken in 4 ways. I have considered it. I have calculated this. Once again, if I am taking 2 steps together in first go, I'll be left with 2 more steps. Now these 2 more steps can be climbed in these 2 ways. We have calculated it. Again, At first go, if I take 3 steps, I'll be left with only 1 step, and this 1 step can be climbed in 1 way. So how many cases are possible for this? It will be 4 plus 2 plus 1. 7. Once again, suppose there are 5 steps. Either I'll take 1 step at first go, 2 or 3. More than 3 I cannot go. That is the limit. If I take 1 step at first go, I am left with 4 steps. Now these 4 steps can be climbed into 7 ways. If I take 2 steps at first go, I'll be left with 3 steps. Now these 3 steps can be climbed in 4 ways. Similarly for 3, we can say it will be 2. So what I am getting this is a sequence which is nothing but 1, 2, 4. From this term onward, 4th term onwards, I can say every term is nothing but sum of previous 3 terms. So it will be 1 plus 2 plus 4, 7. What will be the next term? 7 plus 4 plus 2. 13. What will be the next term? 13 plus 7 plus 4. And in the same manner, we'll calculate it for 10th term. That will be the answer. It's a very good example of Fibonacci kind of series. In Fibonacci series, what will be the general term? General term will be the sum of previous 2 terms. But in this case, we are using extended Fibonacci series in which every term is sum of previous 3 terms. Is it okay with you, all of you? So in the same manner, we'll calculate the 10th term. It was a nice question. Okay. Once again, question number 32. Again, it was a difficult question. Yeah, any problem in this? Should I explain this question? Okay. See, 32nd. P contestants for Miss India 2012 are standing in a circle and are numbered from 1 to P. Started counting from 1 initially in succession. Every second one is removed from the contest and eliminated, and the last one is declared the winner. If contestant number 25 wins eventually and P less than 100, then how many different values can P take? See, in this question, I don't have a better explanation. I did it by taking smaller examples. For example, I took, suppose, number of contestants 1. So who will be the winner? 1. If I take number of contestant 2, 1 again, it will she'll be the winner. 1 1 1 2, sorry, 2 is out, so we are left with 1. If I take 3, now in first go 2 will be out this way. They are standing in a circle. In first go, we are starting from 1. In first go, 2 will be out. Then 3 will be left, 1 will be out. Winner will be 3. If I take 4, 2 will be out, 4 will be out, then 3 will be out, we'll be left with 1. If I take 5, first of all, 2 will be out, then 4 will be out, then 5, 1 will be out, then 5 will be out, we'll be left with 3. So what is happening here? I took more examples. Till 10 I did. So I can generalize this case. Whenever I am getting 2's power, who will be the winner? 1. This is always true. We can see 2 in case of 4, in case of 1 as well, because 1 can be written as 2 raised to power 0. In case of 8, we can see 1 will always be the winner. If I take 2 raised to power k plus something, I'm taking example, suppose I'm taking 3. 3 can be written as 2 raised to power 1 plus 1. 2 raised to power k plus a, suppose. So who will be the winner? 2a plus 1. We can generalize this. See, if I take 3 3 can be written as 2 raised to power 1 plus 1. So who will be the winner? 2 into 1 plus 1. Sorry. If I take 5, 5 can be written as 2 square plus 1. In this case, once again, 2 into 1 plus 1. Now you can relate it. Are you getting me or not? It was a difficult question actually. Whenever we are getting 2 raised to power something, first contestant, she'll be the winner. But if I take 2 raised to power k plus a, so who will be the winner? 2a plus 1. By taking smaller example, we can say that. Whenever you have any difficult question, always take smaller example. We did the same thing in the last question. So now question says 25th contestant, she is the winner. So I can say 2a plus 1 is 25. So a will be 12. So how many contestants are possible? Till 100 we can go. The minimum value should be 25. Of course, if 25th contestant is the winner, there should be at least 25 contestants. By taking numerous values, no Vasudha, we cannot say this. Whenever you are getting a as 1, you will get 3 always. Now by putting k's values, we can find the number of contestants. Now that is manageable, I think. Vasudha, once again, I am taking one more example. Suppose I am taking 10. 10 is 2q plus 2. Now this is new a. So who will be the winner? 2 into 2 plus 1. In this case, 5th contestant, she'll be the winner. I'm not saying 3 is always the answer. No. No, this is not so. For example, once again, I'm taking 7. 7 can be written as 2 square plus 3. Now 3 is the new a. So who will be the winner? 2 into 3 plus 1. I mean 7th. Is it okay, Vasudha? I think you are okay with this. Okay. Let us move to next question. Okay. Question number 33 to 37. Calculations. Otherwise, it was a medium question. Calculation wise, it was difficult. Yeah, any problem in question number 33 to 37? Any problem in this set? If you face any problem in this set, please write the question number 33 to 37. Since I'm getting no answer, okay, Vasudha, 35th you said. Who scored a perfect score in at least one test? I have to complete the set. See, it says all the scores are following some series. For example, I'm taking this series. First one, 5, 8, 12, 17. 5 becomes 8, it means plus 3. 8 becomes 12, it means plus 4. 12 becomes 17, it means plus 5. So we will add 6 to this. So what will be the unknown value? It will be 23. I think you have read the whole set, Vasudha. Okay. Same ways, we'll calculate the whole thing. If I take this third thing, 3 becomes 5, 5 becomes 8, 8 becomes 14, 14 becomes 26. So what will be the next value? It will be 50. That is a question asked. Every test's maximum mark is 50. So what will be the perfect score? It will be 50. Now by using all the directions, we can find the name of the students. I think third student is J. Vasudha, is it okay with you? Or should I explain the whole set? Because you have not asked other questions. So I think you are okay with this set. What do you mean by perfect score? That is 50 on 50. Okay, let us move. (38) Very good question on geometry. Logical 2. Very nice question. Okay, what is the answer in this case? calculative to 38th question. Yeah, any problem in this question? Are you getting me, guys? Yeah, any shortcut, Abhishek? Of course, we can. Amisha, I will say that it was lengthy because of calculation. Otherwise, if you are logical enough in geometry, if you are okay with similarity concept, then it was okay. Okay, let us see. Yes, in triangle XYZ, this angle is 90, which is X. This is Y. This is Z. What is XY? This is 20. YZ 25. XZ 15. Now what is asked? What is the sum of the perimeters of all the triangle formed? Some pattern is given. Then you are doing that pattern, you are drawing that pattern 4 times. Then what is asked? Sum of the perimeters of all the triangles formed. So what will be the perimeter of original triangle? It will be 20 plus 15 plus 25. That is 60. Now what is done? A perpendicular XA is dropped from vertex X onto hypotenuse YZ. A perpendicular is dropped and its name is XA. I am finding value of XA. Can you say area of any triangle is half into base into height? Of course, this is a right angle triangle. That is the easiest way we can find the area of this triangle. It will be half into 20 into 15. If I consider XZ as base and XY as the perpendicular, it will be half into 20 into 15. So it will be what? It will be 150. Now, if I consider YZ as my base, if I consider YZ as my base, which is 25 in this case, and XA will be perpendicular. So what will be the value of XA? It will be 12. It will be 12. Now, now we are having at stage 1, we are having 2 triangles. They are XAZ. Yes, Vasudha. Plus triangle XAY. Now, if I consider the perimeter of XAZ and XAY, I am not going to find AZ and AY. See, if I consider XAZ and XAY, the perimeter of this, it will be nothing but the original triangle plus twice of XA. XA is counted twice in case of both the triangles. So it will be 60 plus 2 into 12. That is 60 plus 24. That is, I'm stopping here only because I have to apply ratio. 60 plus 24. Can you say this, all of you? And once again, can you say in the resultant figure, I can see 3 triangles, 2 smaller and 1 bigger. Can you say all the triangles are similar? Whenever you have similar triangles, the ratio of corresponding sides will be same always. Whenever you have 2 similar triangles, the area will be in the ratio of square of corresponding sides. Is it okay? What will be the areas ratio? It will be square of the corresponding sides ratio. And what will be the perimeters ratio? It will be same as ratio of the corresponding sides. So at stage 1, see 60 was the original thing. At stage 1, I am adding 24 to this. I mean 24 by 60. That is 2 by 5. It means I am taking what? Original plus 2 by 5 of the original. That is 7 by 5. See, what was the original thing? 60. What will be the new thing? 61 plus 2 by 5. You draw many triangles. You draw any number of triangles. The resultant triangles will be similar to the original triangle. Whenever you have similar triangles, there will be a pattern. There will be a ratio. In case of perimeter, the ratio will be same always. So, if I am considering original triangle as 60 perimeter, I am adding 24 to this. What will be the next thing? It will be 60. 1 plus 2 by 5. Again, I will take 1 plus 2 by 5th of that. And this process is done once again. So this will be the answer. So answer will be 60 plus 60 into 7 by 5 plus 60 into 7 by 5 whole square plus 60 into 7 by 5 whole cube. And one thing more, you should remember whenever you are drawing, once again infinitely many times, you are drawing something inside a triangle or inside a circle or inside a square, inside any figure, you'll 90% this is the case, you'll get a GP with infinitely many terms. But this process is repeated 4 times. Is it okay with you, all of you? I will not draw any other triangle now. I'll take the pattern only, since all the triangles are similar. Okay, that was a difficult question to explain. Now question number 39. Many of the students have marked second option, obviously, which is not the answer. What is the answer in this case? It will be third. It was a bluff. Okay, any problem in this question? Okay. See, I'm not going into calculation. See, what is the thing given? That digester is in the form of a cylinder with height 1 by 4 of its diameter, surmounted by a hemispherical dome, has volume 792 cubic feet. Okay. First of all, I'm drawing the figure. This is the figure. By using the calculation part, we can say, by using the formula, see what is the volume of the cylinder? That is pi r square h. What will be the volume of the hemisphere? It will be 2 by 3 pi r cube. And that is given as 792. There are some conditions given. By using those conditions, we can see that this is 6. This is 6. And this is 3. And this is 6. I think that is manageable for you to find the radius of the cylinder and height of the cylinder. So I'm not wasting my time on explaining this. Now what is the condition given? Yeah, this is given that Ravi wants to build a digester for a biogas plant on a rectangular plot. There is a rectangular plot its dimensions are 28.8 feet into 15.7 feet. And so that a third of the height of the digester is below ground. It means what? What is the height of this complete height of this digester? This is 9. So he wants 3 feet below the ground. That is 1/3 of 9. So the earth that is dug out is spread evenly across the remainder of the field. That was a catch here. So see, what is the thing? Suppose you are digging up to h height. So what will be the volume of the earth dug? That will be in form of cylinder only. It is a case of visualization. Are you getting me now? Please confirm. Okay. See, suppose this hole is dug up to h height. So what will be the volume of earth dug? It will be in form of cylinder only. It will be pi r square h. And this earth is evenly distributed on this plant. We want the complete height to be 3. So if h is dug, it should be 3 minus h. Then only it will become 3 feet. Am I okay with this thing? Because that was the main thing here. Is it okay? So can you say earth dug, its volume should be equal to earth spreaded on the ground. Now the earth spreaded volume, it will be in form of a rectangle with a circular hole in this. Now, am I loud and clear? Is it okay, all of you? Okay. Is it okay now? Amrit? Okay. See, now what is the volume of earth spreaded? It will be 28.8 into 15.7 into 3 minus h. This is 3 minus h. Minus, now there is a circular hole in this. So what will be the area of this circular hole? It will be in form of cylinder, pi r square h. What will be the height of this circular hole? It will be 3 minus h. Is it okay? It was a calculative set, but you are getting 2 questions corrected. What is the earth dug volume? This will be 36 pi h. What will be the earth spreaded volume? It will be 28.8 into 15.7 into 3 minus h. This will be a cuboid with a hole in it, minus what is the hole's volume? It will be pi into 6 square 3 minus h. Now if you solve this, you will get h as 2.25. Again calculation, it will be 2.25. That was a thing in this case. So it will be 2.25 divided by 9. That is the answer. that will be 25%. Or if you can go by approximation, of course you are digging out the earth and you are spreading it. Of course the height of the earth dug should be less than 3 because you are spreading the earth. That's why height should be less than 3. If I take height as 3, answer should be 33.33%. If I am getting less than 3, answer should be 33.33%, less than that and close to that. It will be 25%. This guesswork was okay. Yeah, any still? Barsha, I'm not getting you. See, you want the digester should be 3 feet below the ground. Now, what is 39th question? The depth of the hole dug in the field is what percent of the total height of the digester? Suppose you are digging up to 3 feet. So, answer should be 3 by 9, 1 by 3, which is 33.33%. But 3 actually is not the answer because you are digging out the earth and you are spreading it. You are spreading this earth on the rectangular garden, rectangular plant. That's why if you take 3 feet hole by spreading this earth on the ground, the height will become more than 3. That's why actual height should be less than 3. So answer should be less than 33.33%. That is 25%, but there is one more option, 16.66%. That's why I solved the whole question. Yeah. Any other problem in this question? Is it okay, all of you? Okay, let us move. Question number 42. We have discussed this concept in the last session, those who have attended. 42nd and 45th. Please write the question number if you face any problem in these two questions. 42nd first of all, 45th to Amisha. Okay, wait. 42nd first of all. Before explaining this question, let me explain a very good property of algebra, that is arithmetic mean is greater than equal to geometric mean. That is a complete property that is greater than equal to harmonic mean. Equality holds if all the numbers are same. Let my numbers are say x, y, z. I am explaining this property in case of 3 variables. What is arithmetic mean? Sum of observation divided by number of observation. What will be geometric mean? Product of all the numbers raised to power 1 upon number of observation. I am not considering this part because that is not useful in this explanation. So that is arithmetic mean greater than equal to geometric mean. Now equality holds if x is equal to y is equal to z. Now come to the original question. It says a plus 2b plus 3c plus 4d is equal to 36, and you want the value of a into b square into c into d square. A complete case of manipulations. See, you need 1a, you need b 2 times, you need 1c, 2d, you need 2b. So I am splitting this term b plus b to get 2 b's. We need 1c, so I am taking as it is 3c. We need 2d, so I am taking 4d as 2d plus 2d. That is given as 36. That is a manipulation we have to do. Now I'll apply am greater than equal to geometric mean on these numbers. Arithmetic mean is always greater than equal to geometric mean. So arithmetic mean is a plus b plus b plus 3c plus 2d plus 2d divided by number of observation greater than equal to geometric mean. Now what will be the geometric mean? Product of all these raised to power 1 by 6. Now we know the value of this, that is 36 by 6 greater than equal to, I'm taking raised to power 6. So we are left with a into b square into c into d square, and this 3 to 2, 12 is into multiplication. Now you can solve it, you will get the maximum value. Is it okay with you? Yes, all of you? Suppose instead of this, a into b square into c cube into d square is asked. In case of c cube, you will write this as c. You will adjust the expression according to the multiplication. Is it okay with you? Okay. Now the next question. Yeah, 45th. Nice one. A good example of repetition in permutation and combination. 45th is Amisha and Shreya. Okay. Amisha and Shreya, see, before taking this example, I'm taking one more thing. Suppose I'm taking a smaller example. Suppose you are sitting at this point A and you want to go to B. Only in these direction you can move, and at once you can take one step. One step is equal to 1 unit. In how many ways you can go from A to B? That is my question. Suppose I am drawing a permissible path with blue color. Suppose this is a permissible path. Now I'm writing this path. In first go you are taking a right, then you are moving upwards twice by taking 2 steps, then you are moving right 2 times, then upward 3 times, then right 3 times, then upward 2 times, then right 2 times. Is it okay with you? R stands for right and U stand for upward. Okay, so if you take any arrangement of this, see, if you want to go from A to B, you have to take these many rights always. These are 7 rights. And you have to take these many U's, and they are 7 U's. You draw any path, you have to write 7 times R and 7 times U's. You take any arrangement of these, you will get a path. So by taking the concept of repetition, 7 R's and 7 U's can be written as in a line. They can be written in these many ways. So these many ways are possible from going from A to B. Is it okay with you? That was a smaller example. Yes, all of you. Now I'm going to question. A man works in a building located 7 blocks east and 8 blocks north of his home. I'm not very good at drawing. 7 blocks east and 8 blocks north of his home. This is home and this is office. First of all, he is going to office from his home. That can be done in 15 factorial by 7 factorial, 8 factorial. Now I'm not doing the drawing part. I think you are getting this. From home to office, these many ways are possible. Now He reached his office and then walks to a supermarket located 2 blocks east and 4 blocks north of his home. 2 blocks east and 4 blocks north. It means there is the supermarket. From office he is going to supermarket. So it will be 5, it will be 4, and he wants to take the shortest route. So that can be done in from office to supermarket. How many ways are possible? It will be 9 factorial divided by 4 factorial, 5 factorial. Now this is the answer in this case. Is it okay with you? That is the repeated application of the concept we have discussed, the repetition thing. Yeah, any one of you, any problem? Is it okay, all of you? Okay. Okay, let us see the next question now. 48th and 50th. 48th, hit and trial only. 50th was very easy question if you go by putting values. Okay, any problem in these two questions? Please write the question number in the chat box. 48th, 50th as well. Okay, first of all, 48th question. We can go by value putting as well. It says x square plus y square minus xy is equal to x plus y. There can be numerous things we can do. We can make complete square, but that will be difficult one. I can see this expression. This expression is used in x cube plus y cube. So I am multiplying this expression by x plus y. By putting values, by hit and trial, if we go directly, we can skip many cases. So I am trying to make an expression. It will be x cube plus y cube. It will be x plus y whole square. Now x plus y whole square. Since integral values are asked, positive integral values rather, integral solutions are asked. So its square will be integer always. Now x plus y can take value 0, 1, I'm taking the complete value 4, then it can take value 9, 16, 25, 36, because we are talking about a square. So x plus y become correspondingly 0, 1, 2, 3, 4, 5, 6 and so on up to. Now x plus y whole cube we are getting 0. I'm writing xy here. It can be possible if I take 0, 0. That is a one solution possible. Now I'm taking the second solution where x plus y is 1 and x cube plus y cube, that is also 1. So I'm getting 0, 1, 1, 0. These two solutions are possible. Now I'm taking this. X plus y is 2 and x cube plus y cube, that is also 4. If I take this, now you can try it. See, how can it be possible? 4 can be written as 0 plus 3, not possible. Or 2 plus 2, again this is not possible. So we'll not get any solution from this. Now I'm taking this 9, where x plus y is 3. Hit and trial only once again. X cube plus y cube is equal to 9. Now 9 can be written as sum of 2 perfect cube, that is 1 plus 8. And it can be written as 1 plus 2. So 1, 2 and 2, 1. That is also possible. Similarly, x cube plus y cube, that is 25. X plus y, that is 5. Again, this is not possible because 25 cannot be splitted into sum of 2 perfect cubes. See, 25, if you write 1 plus 24, you can write it as 4 plus 21 and so on. So there will not be a possible case in this. By same way, I'm left with one case, I think. X plus y is equal to 4 and we are getting x cube plus y cube, that is 16. Yeah, this is possible because 16 can be written as 8 plus 8, where 8 is a perfect cube, so it will be 2 plus 2. So these many solutions are possible by hit and trial. That is the only technique we can do here. That's why what is the answer in this case? 6 solutions. Is it okay with you, Olive? Okay. Now let us move. Question number 50th, Amisha. See, whenever you see any n, it's better if you go by value putting. A box contains n chips numbered 1 to n, 1 by n. 1. N chips are removed at random from the box. This. E1 is the event that the n chips are removed without replacement. And E2 is the event where with replacement. P1 and P2 are the probabilities that the number on the chips removed in E1 and E2 respectively follow this sequence. See, I'm taking n as 1 first of all. It means there is only one chip. Can you say in that case P1 should be equal to P2? If I'm taking only one chip, there will be no question of with replacement and without replacement. They both will be same. That's why there will be no difference in P1 and P2. That's why they both should be same. That's why first and second option, they cannot be the answer because there is no equality in this. Now I'm taking n as 2 since I'm left with third and fourth option. If I take two chips, you are drawing two chips. First of all, P1. What is P1? Without replacement thing. Now, how many cases are possible? If I take 1, 2 without replacement, they can be either 1, 2. You will take this sequence or 2, 1. We cannot take 1, 1 because that is a without replacement question. My favorable case is 1, 2. It should be followed. It should follow the sequence 1, 2, 3, so on up to n. It means ascending series. So what is the probability? Half. Now I'm taking P2 with replacement thing. How many cases are possible? They can be 1, 2, they can be 2, 1, they can be 1, 1, they can be 2, 2. Why? Because with replacement, putting back the chip. So what is the permissible case? What is the favorable case? So what is the probability? 1 by 4. I'm using the same definition, number of favorable cases divided by number of total cases. So P1 is always greater than P2. That's why third option, this is the answer. Is it okay? I'm not going to explain this question by using n only. It's better whenever you see any variable, you take values. That can be the easiest way. Okay, now the last question. It was a very nice set, good one. Only 3 questions were there. Yeah, I have picked one question of this. That was a difficult one. Yeah, any problem in this? This is the question. What is the least number of players who played fewer than 240 matches but scored more than 11,000 runs? Should I explain this sum? Okay. See. See, what is the question? What is the least number of players who played fewer than 240 matches? I'm taking this information. Matches we are talking about. Fewer than 240 matches, but scored more than 11,000 runs. And we want to minimize it. See, the key line was the last thing. Each of these players played a distinct number of matches, and between any two player x and y, if the number of matches played by x is more than that by y, then x should have scored more number of centuries and more total runs than y, and vice versa is also true. It means if matches played are more, total runs scored are more, and number of centuries scored are more. So I can do one thing here. I am taking all the players as P1, P2, P3 and so on up to P80. Why? Because there are 80 players. Suppose P1 is the best player, P2 is the second best player, P3 is the third best player, and so on up to. And suppose they are standing in a line in this order only, P1, P2, P3, so on up to P80, and they are standing in ascending order. Ascending order means P1 is the excellent player, best player, P2 is the next to best player, P3 is the next to best P2 player, and so on up to. So now my condition was P1, P2, so on up to P80. What is the least number of players who played fewer than 240 matches? Fewer than 240 matches means these many matches. And there is one more condition, more than 11,000 runs. By using that table, the first column in number of matches said more than 240 matches is equal to 38. More than 240 matches, there are 38 players, and they'll be P1 to P38 because they are the best player. P1 to P38, these players are playing more than 240 matches. If I take reverse of that, less than equal to 240 matches, they'll be remaining players P39, P40, so on up to P80. Are you getting me, guys? All of you? It is a good logical sum. Now I'm taking the another condition. By using table, we can say less than 11,000 runs, there were 25 players. Less than 11,000 runs. If they are scoring less than 11,000, they should be last 25 players. Last 25 players will be P55 to P80. Can you say this? P55 to P80. So I can say greater than equal to, I mean reverse of that, greater than equal to 11,000 runs, they'll be P1, P2, so on up to, sorry, it should be P56 in this case. Last 25 players we are talking about, P55. Are you getting me? Now I have this information, less than equal to 240 matches and greater than equal to 11,000 runs. Now we want these two conditions together. If I club these two conditions, I can say both these conditions will be satisfied in these players, P39, P40, so on up to P55. These players are 55 minus 39 plus 1. They'll be how much? 17. 17 players are there. But there was a flaw. What was that flaw? See, this range is for less than equal to 240 matches and greater than equal to 11,000 runs. But I need this less than 240 and greater than 11,000. For this condition, there is one word, least number of players. So I will consider that P39 is playing exactly 240 matches because I want to minimize it. And for P55, I'll consider he is scoring 11,000 runs exactly. So equality is out. That's why we are subtracting 2 players and we are left with 15. That is the answer in this case. Vasudha, whenever you want to count the number of items from 39 to 55, it will not be 55 minus 39, rather it will be 55 minus 39 plus 1. Once again, let me write. See what I am saying. From 39 to 55, how many numbers are there? They are not 55 minus 39. They are 55 minus 39 plus 1. That's why we are getting 17. Is it okay, Vasudha? And we want to minimize this range. That's why we are subtracting 2, because we are considering that for P39 he is playing 240 matches, and P55 he is scoring 11,000 runs. We don't need equality here. Yeah, still any problem in this question? It was a good set. That was the most difficult question in the set. Okay guys, that's it for today. Yeah, still any problem in any of the questions? Some student, he has asked me one more question. I think that was question number 25. Yes, Raghav. Yes. 25th question. Okay, see, I don't have a presentation, a slide for this question. See, I'm reading this. A string of 1996 digits begins with the number 6. Any number formed by 2 consecutive digits is divisible by 17 or 23. First of all, how many 2-digit numbers are divisible by 17? They are 17, 34, 51, 68, 85. That's it. Because more than 85, it will be a 3-digit number. Again, for 23, it will be 23, 46, 69 and 92. We are considering 2 digits only, 2-digit number only. That's why I'm stopping here 92. Now, what was the question? Question says your number is starting with 6. Any number by using the consecutive 2 digits, it should be divisible by either 17 or either by 23. Now, with 6 there are 2 numbers, 68 and 69. Suppose I'm using 68. Now 68 is divisible by 17. Now my other number, it should be either divisible by 17 or 23. That's why I can use 85. Because in this range there is only one number which is starting with 8. Are you getting me, Raghav? This is divisible by 17. Now with 5 I can write 51. Again by 17. Now with 1 I can write only 17, which is divisible by 17. Now there is a problem. See, with 7 we don't have any number which is starting with 7 and divisible by 17 and 23. That's why this case is not valid. What is the condition? The number formed by any 2 consecutive digits should be divisible by 17 or 23. That's why I'll take another combination. That is 69 I am taking. Now this number is divisible by 23. With 9 I have only one option, that is 92. Divisible by 23. With 2 I have only one option, 23. Again divisible by 23. With 3 I have only one option, 34. With 4 I have 6. See, now 6 is coming. I started my number with 6. I am getting 6 again. So I'll get the same series, 6, 9, 2, 3, 4, 6, 9, 2, 3 and so on up to. So what is the thing here? I'm getting a number 69234, 69234, 69234. How many digits are written? 1996. What is asked? 1996 digit. See, I am getting blocks of 5. You are getting blocks of 5 and they are repeating again and again. So, can you say 1996 when divided by 5? What is the remainder left? 1. It means what? We'll get many blocks of 5, numerous blocks of 5 with 1 digit extra. What will be that 1 digit? That will be 6, of course. That is the answer in this case. Is it okay, Raghav? Okay. Now, Shreya, 20th was very easy question. Amrit, you just wait. I'm coming to your question 31st. Again, it was easy. It's better if you read explanation. Shreya, yes, of course. See, a square plot of side a square plot of side 300 meters. This is the center. Divide into a pentagon and a two congruent trapezium by joining the center of the square plot with the midpoint of one side and two other point on the adjacent sides. Two congruent trapezium. Yes, this way. You join middle point of one side and two other point on the adjacent side, this way. Now this is a trapezium and a pentagon. Since all the things are same in this case area wise, what will be the area? 300 into 300. So what will be the area of every diagram? It will be 300 into 300 divided by 3. Is it okay, Shreya? Okay. Now Amrit, your doubt, question number 31 you said. See, it says, some chocolates are distributed among 3 girls in such a way that the product of the numbers of chocolate with any 2 of them is 225. Let the numbers are x, y, z. Now this is given xy, yx, yz. Sorry, xy, yx is equal to zx. This is given as 225. If the product of the number of chocolate with the 3 girls is as large as possible, what is the number of chocolates distributed? Okay, now we can multiply these things. So I can see x, y, z, its whole square is nothing but 225 cube. What is 225 cube? It will be, what is 225? It is 15 square. So it will become 15 raised to power 6. So we can say x, y, z is nothing but 15 square. 15 cube, sorry. Now by using these things, xy is equal to 225. I am putting value here. 225 into z is equal to 15 cube. So obviously z will be 15 in this case. In the same manner, we can say that x, y, z, they all are equal, 15, 15 and 15. Is it okay, Amrit? Okay. Now question number 26. It was a basic question of remainder. Amrit, you know how to calculate the remainder? I'll explain one part. See, which of the following will yield a remainder of 7 when divided by 9? I'm taking this 112. I'm dividing it by 9. The remainder should be 7 always. Okay. So, I can write this as 3 because this 112 when divided by 9, what is the remainder? Sorry, 4. Now you can apply cyclicity here, or you can go by Euler number. There are many techniques we can apply, but now I'm applying cyclicity because I think cyclicity is the easiest thing. Now 4 raised to power 1 when divided by 9, what is the remainder? 4. 4 square, 7. 4 cube, what is 4 cube? That is 64. 1. So I'm getting a 1 here. So what will be the cyclicity in this case? It will be 3. Now we'll divide this power by 3. If we divide this by 3, it will be exactly divisible by 3. If this is exactly divisible by 3, what will be the remainder in this case? It will be 1 always. That's why what is the remainder in this case? 1. But we need 7. We'll check for every option. We'll get the remainder then. Is it okay, Amrit? Yes, all of you? Okay, that's it for today, guys.